take a peek at my first example. I think relative to what you and I have been doing so far, that's a relatively nasty example. At a glance, it doesn't seem to be the case that a U sub doesn't equal 4me at a glance. At least not maybe a standard U sub. Certainly, though some are different from squares, the subs trig subs are out. There aren't any trigonometric expressions, so it's not a trigonometric integral. So, I think the only thing left now is going to be committing to partial fraction decomposition. And if I commit to partial fraction decomposition, can you guys imagine how I'm going to break this up? No, I'm talking about, you know, what you did to homework last night. At home. In class.
AX minus B or plus B.
You know what I was hoping you'd say? I was hoping you'd say, we're out of luck. Because I think committing to partial fraction decomposition only worked when I had a proper rational expression, duration of one polynomial to another. Did you guys see my point? I think for that reason I can't commit to partial fraction decomposition. It sounds like I've exhausted all my possibilities. I actually no. Sorry, I did forget one. Integration by parts. Nah, doesn't seem like it does anything for me. But what if I go back to my first technique? Committing to a U sub, but I'm going to use a very special U sub. One that allows me to get rid of the radical expression in the integrand's position. For that reason, I might refer to this as a rationalizing substitution. I refer to this as a rationalizing substitution because it rationalizes what you see in the integrand. It gets rid of the radicals. To do that, I'm going to take what the heck I have for a radical, that would be this mess right here, and give it a new name. Now, committing to the substitution, I think du is this. And I'm just tired of dealing with it. So if you guys don't mind, before I relate du to dx, can I just make my life easy? I'll get rid of the radicals. I'll square both sides. It just makes for an easier relationship between du and dx. That's not bad. Now, committing to this particular special rationalizing U sub, I think my original integral, can you guys help me with this? Am I writing it down correctly? I'm just too far away. Is it x minus 1? Is that correct?
Yeah.
And if it is, let's dive in and just commit to my substitution. Symbol by symbol. I think another name for downstairs is chu minus u. I think another name for the dx is clearly 2u du. Oh, but shoot, wait a minute. I have to put another name for x, but that would be nice. Or shall I say, in the end, that gives me a 2u cubed plus 2u all over 2 minus u with respect to u. Shoot. Is that really helping?
Yes.
How?
You can split it up over the subtraction sign, and then you just cancel that terms. Oh, I'm sorry.
Or couldn't you just do long division and simplify it?
Now, I agree with poly long division.
Yeah.
Oh, I'm tired though. I don't want to go through all the work. So as an alternative, what's your alternative to poly long division? What's your alternative to poly long division?
You can
True. In this case, I could use synthetic division. What's the shortcut for that? The number 0. So we'll add them to the form of 0. I got a 2u cubed. Why don't we just add to that, how about a negative? 4u squared. At least now, I guess in cancellation, don't I?
Where did you get that from?
I did this. Sorry, I'll put it back. I'll get rid of it. Wouldn't it be nice if upstairs I sort of like had a factor of u, but where for my constant term it was twice the coefficient but with a sign change? Okay, so that's not a u, it's a u cubed. Same idea though. I've got 2u cubed, so I'll add the next lower level term, lower power term, where I get a sign change and I double the coefficient. So that when you look at this one fraction, there is a u minus 2 that cancels upstairs and downstairs. It's not legal. I got to put it back in. So I'll put back in my positive 4u squared, so that I've effectively added by something that's basically equal to 0. Oh, did I forget a constant or another term? So help me with this. Yes or no? Does that reduce what quite nicely? Did I walk in the right class again?
Yes.
Yes, I can.
Yes, it
Would you
does.
agree with this? That if what I said is true, with this funny looking form of zero out of there, don't you agree that with this first integral, this one right here, if I pull out a 2u squared, look what's left over? Look at that wonderful cancellation. I'm serious. Doesn't that make my life easy? Now, I know I'm lying, you guys. I'm lying because my hand's hiding something. It's hiding all this other garbage. But let's see if the same thing holds true here with these two terms. What's left over? I've got a 4u squared plus something over negative u plus 2. Let's take a peek. I want the coefficient of next lower power of u to be twice this coefficient, or shall I say twice that coefficient, with a sign change. That'd be a minus 8u. Oh, but I already had a plus 2u. So, and I added negative 8u. Since I added a negative 8u in there, I better add it back in, and I still got my 2u up there. And at least now with this integral right here, this is nothing more than the integral where if I pulled out a 4 and a u, look what's left over. That's really slick again. Because this just simply gives me the integral of 4u. Yes?
Would on the left-hand side it'd be negative 1 when it cancels out? Or am I just not seeing
You know what? I think it's a negative sign for both of them. I think I made two mistakes. Thank you. Did you guys catch what he said? Not direct cancellation, but a factor of negative 1 left over. Here, too, I made the mistake twice. I think here as well, I can't cancel, but there is a negative factor left over. Can I put in the other stuff? I think with what remains, oh shoot, what does remain? Would that be this?
Yeah.
The integral is 6u. Excuse me. I can't add. 8 plus 2 is 6.
Yep.
Bless you. So, you guys finish this up. Tell me what to write, please.
What, minus
Oh.
20?
Minus 20. To make it legal. Oh, but that means when I take a mathematical ax, whoops, here, I've got that first integral, which is nothing more than the integral of, let's pull out a 10. Here's what's left over. Here's what's downstairs. With a bit of cancellation. Change signs. That's a piece of cake. Oh shoot, did I mess up? I forgot something. I forgot my plus 20. Over my negative u plus 2. Yes or no answer. Is that a piece of cake?
Yes.
Absolutely. I think in the end, all I really have, remains standing. I don't know. It's too far away again. Is that a 2/3 cube? Is that a minus 2u squared? And is that a minus 10u? And finally, is that a plus, or excuse me, minus 20? Natural log of the absolute value of, I don't remember,
G plus 2 plus
2 minus u.
2 plus 2 vis-a-vis.
I'm here to attack. Is that okay so far?
Looks good.
Yeah. Hold on. Sorry, just substitute.
Oh yeah, you have to back substitute.
Say it again, I'm sorry.
How did you make the negative 4u squared at first?
Here's why. Because I know if I want to cancel upstairs and downstairs, my numerator has to behave this way. It has to have the quality that going from u to the first down to u to the 0, decreasing u by a power of 1. Notice how the coefficient of u changes signs and doubles. And since here I had a u cubed term with a coefficient of 2, for the next lower u term, I'm going to change sign of 2 and double. So that I get this kind of cancellation here. I was just forcing the cancellation. And you guys, I did way too much writing on the board. It's because I'm standing in front of class. I don't go through all this garbage. I do everything at once, in a snap. You might yell at me by saying, look how many steps you got on the board. It's way too much work. The way I'm writing it, you're right. But I'm trying to explain my process. I think if you're going to go through all this work, maybe you should give up and say, forget it. I don't want to do it. I'd rather use polynomial long division. You get the same result. David.
Now on the second step of the process, when you go from there to there, when you cancel the terms,
You mean the factors?
the factors, wouldn't the factor in the denominator's place have to have parentheses around it to make it identical to the top to cancel?
Very nice, I agree. However, I think this very long division bar is acting as a simple grouping. So the very long division bar is acting as a set of parentheses downstairs.
But that's not the same.
I know, you're right. There's a sign change, so I pulled the sign change out.
Oh, I see.
Or David, how about if I do this? Don't look at that. Let's pull a negative one out and write this instead.
Yeah.
Oh, excuse me, I made a mistake. I meant that.
Yeah. Okay.
Now cancellation, but the negative sign I pulled out.
Gotcha.
Yes, sir.
Did you explain what happened to the negative out in front of the first u squared term when you integrated it?
No, I can't tell you what happened to it. Sorry. Thank you. Just got these flying negative signs all over the place. Do you guys want to see me perform Pauli long division? See if I get the same thing?
Yeah.
One yes. Let's perform Pauli long division.
Sweet you guys. Still learning.
Everybody, I'm looking right here, my first U integral that apparently doesn't have integral symbol, jeepers. No, not this one, how about this one? I'll divide here. And so, everybody, pulling out my nifty little division bar, I'm going to put in the dividends position, my numerator, which is 2u cubed plus 2u. Did I say that correctly?
One question before you start.
Yes, sir.
You won't use back substitute now, correct? To get to our next step.
Can you say it one more time?
You need to back substitute.
Oh, I'm not denying I'm not finished. You're right, I'm not finished. I still need to go. I'm just saying, so far, so good. But you guys, let me go ahead and write my denominator, which is negative u plus 2. So I'll put that in the divider's position, and let's play the game. The game we're going to play, is concentrating on leading terms. This leading term in the divider's position goes in the leading term in the dividend's position how many times? 0. Say it again.
Negative.
I think negative 2u squared times.
Oh, never.
And committing to that, I will multiply this particular term in the quotient position to the entire divisor, but that gives me a product as a positive 2u cubed minus 4u squared. And now let's subtract a second from the first. How many u cubes do I have? 0. Well, I better. If I don't have 0 u cubes left over, that means I made a wrong decision for the first term in the quotient position. So, I'll run with it. Subtract the second from the first, that gives me a positive 4u squared plus 2u dropping down the next term. And, let's play the game again. Leading term in the divider's position goes to the leading term, and what the heck is left over how many times?
Negative 4.
Negative 4u times. There's my next term of the quotient position. However, negative 4u times the entire divisor gives me a product of positive 4u squared is that minus 8u. One more time. Subtract the second from the first gives me a positive 10u. I'll drop down the next term, which is just 0. But now, in red, leading term divider's position times what? Gives me the leading term, what the heck is left over? Negative 10. And therefore, that's the last term up in the quotient position. Hang the consequence. Negative 10 times the entire divisor is this. Subtracting. Let's do it again. What do you multiply by this to get this?
2
Okay, so therefore it's not a polynomial expression. I'll stop. As a matter of fact, the division algorithm told you guys in the past that once what's down here has a degree less than the degree divisor, we stop the division algorithm process. So I won't take it one step further. I'm done. By the way, that means here's my quotient. And that basically means I've got my negative 2u squared, oh there it is, minus my 4u, oh there it is, minus my 10, oh there it is, plus the remainder over the divisor, which is 20 over negative u plus 2, there it is. So you don't like my funky way of adding my darn zeros in integrand's position, don't listen to me. That'll always work. Is that okay? And like Mario was suggesting, maybe I could use synthetic division as well. Makes my life a little easier. Yes?
What is this called?
if I'm not too silly, adding 0.
Okay, and is there any situations where, we would have to do this where, division wouldn't work?
No. That's why I'm saying, if you don't want to listen to me, drop it like a rock. That'll always work. Yes, sir.
I don't know why we can't just do 2u thirds plus 2u over 2 minus 2 thirds plus 2u.
U cubed plus 2u over u. Here's why. Because I think when it comes to an a over b plus c, this is not the same as a over b plus a over c. Unfortunately, I can't split the denominator's position. I can in the numerator's position, but these are not equivalent. Yikes, you guys, I still haven't finished what's left.
Oh,
Yeah,
back
just back
substitute.
substituting. Would you mind if I don't?
Yeah, I'll do it.
Can I save some time on the clock and go to the next one? But you would back substitute, wouldn't you?
Yes.
My next example. I still think that's a really nice candidate for this rationalizing substitution. After all, look at the radicand's position. I think I got the sum of 2 cubes, not squares. That doesn't look pretty accommodating to a trigonometric substitution. So, let's u sub it out. Let's I allow u to be the square root of whatever's there. Only because I'm lazy. I don't want to relate du to dx yet, because that involves differentiating the square root of a cubic expression. Instead, before I relate du to dx, I'll square both sides. Because now when I relate du's to dx's, at least there's no roots involved. I just think it makes my life slightly more easy. That being the case, here too you guys help me with this. Is it 1 over x times the square root of x cubed plus 1? Is that what it is?
Yeah.
Okay, if it is, let's commit to the substitution. Symbol by symbol. Downstairs, what's another name for x?
U squared plus 1, the cube root of that.
So you're saying the cube root
Yep.
of a u squared plus 1.
Yep.
Is it u squared plus 1 or u squared minus 1?
Minus 1, minus 1.
What's another name for a square root of junk? What's another name for du? Sorry, did I misspeak?
2u du. Sorry, no, 3.
Gosh, I'm getting so sloppy, sorry. It's a dx. Ay, ay, ay.
Divided by.
So you're saying 2u du divided by, what were you going to say?
3x squared.
3x squared. But x squared is nothing more than, everybody? X squared is nothing more than,
Cube root of u squared minus 1 squared.
very nice. So u squared minus 1 to the 2/3. Shoot, you guys, maybe this isn't working. Actually, I said that rationalizing substitution is supposed to get rid of radicals. I really miserably failed, didn't I? I said I really miserably failed, didn't I? You want me to say it 3 times?
I think it is like you're saying.
No, I didn't fail at all. I think this looks rather nice. Watch. Use cancel. Can I ignore those coefficients? Can I just get rid of them? Look what's left over. U squared minus 1 to the 1/3 times u squared minus 1 to the 2/3. Isn't that just simply u squared minus 1? What do you think? Personally, I would never have done this. I would have been this lazy. I would have said, well, let's jump around a little bit. Inside the big red circle, clearly with this u sub, that's nothing more than this. But because I got a factor of x here, but eventually I went to x squared, I would have cheated. I would have said, put it in and compensate. So another name for x cubed is u squared minus 1. And the x squared dx upstairs is nothing more than 2/3 u du. And with a tad bit of cancellation. Oh, check that out. That's exactly what I have.
Can we do that again? I missed it.
Yes.
Yeah.
Can I erase it then? Let's start from scratch. I'm just saying this. This looks so convoluted. I mean, personally, it's not what I would have done. Because I think, oh shoot, I'm introducing more cubics. I know that I get rid of them in the end. I'm just saying, I think something cleaner would be this. Let's you and I dive in, and symbol by symbol try to get rid of things. So I'm back to where I was. Let's jump around a little bit. The dx is shoot, it's got an x squared in there, darn it. Has this got an x squared in there? Let me put one in. It's not legal. You gotta multiply the denominator by x squared as well. Now, I think another name for what's inside this black circle is just 2/3 u du. And I think another name for what's inside this red circle is, oh, that's easy, that's just a u. But now, another name for what you see inside this blue circle, the x cubed, another name for that is just a u squared minus 1. I said blue, sorry. And with a tad bit of cancellation, pretty slick stuff, you guys. That's exactly what I had before. I'm just saying, there's different ways you can look at this. That's what I would have done. Yes or no answer. Is that a piece of cake? Yeah, it is. That's simply going to give me nothing more than 2/3 times the integral of, well, something over u plus 1 plus something over u minus 1 with respect to u. So everybody, just applying a tad bit of a partial fraction decomposition, would that give me a negative 1/2 and a positive 1/2 if we do the PFD in our heads? Is that okay?
You assume we can do that in our heads?
Well, just a little bit. And in the end, I think that gives me 2/3 times, did I misspeak? Sorry. I guess I should say, it gives me 1/3 times the natural log of the absolute value of u minus 1 to u plus 1. Of course, in back substituting, I guess that leaves me 1/3 natural log of the absolute value of the ratio of this u minus 1 over this u plus 1. I think that looks beautiful. I hope. This silence treatment of yours is really getting to be a habit.
Is that I think you said last time that's an inverse hyperbolic tangent?
Yeah, you don't have to listen to me. You could have just stated the answer in terms of inverse hyperbolic tangent. But, algebraically speaking, I can rewrite the inverse hyperbolic tangent as a log of a ratio. Oh, that's exactly what I am. So, guys, with everything you know about hyperbolics, and I know sometime this summer session I have to give you a mini lecture on that. Yes?
So with the first example and this example, I don't
Yes.
see the connection. What are you trying to teach us?
I think there's a huge connection. Because I think with the first and second examples, I was saying, you know, nothing else seems to make sense in terms of the techniques of integration I've given you so far. So how about this as an overall umbrella for all these? I got radicals. Let's just let u be that radical expression. I let in this example u be this radical expression. In my next example, I'm going to let u be this radical expression to get rid of radicals. And that's why I subclassify this technique as rationalizing substitution. Get the phrase rationalizing substitution, because I'm undoing the radicals. Sir?
Now that we know this technique, can we use this instead of the non-tree substitution?
If it helps.
This
If you think it's better.
Because it still just gets rid of the question.
If you get if it succeeds in getting rid of all the radicals, go for it. So let's try my third example. If I'm not being too sloppy, everybody, that's an index. That is a cube root, not a square root. By the way, am I done over here? I want to raise if you have questions.
Yeah.
Okay. You're okay with it? Let's get rid of it.
Before you
Yes,
do that,
David.
how did you do that so fast in your head, the partial fraction decomposition?
I don't know. The numbers are just natural to me.
So if it's u plus 1, u minus 1, it's just negative 1/2 and positive 1/2?
Well, do you believe me?
Huh?
Do you believe me?
Sure.
Well, no, don't be like that. I mean, if you multiply this one by u minus 1, this by u plus 1, don't the u's cancel? Here I get a negative 1/2 u. Here I get a positive 1/2 u, but added they get 0 u's. But Negative 1/2 times negative 1 up here is positive 1/2, plus another 1/2 is positive 1. Oh, look at that. Exactly what I have.
Okay.
To me, partial fraction decomposition is first grade addition of fractions in the reverse direction. I'm being honest.
I haven't been in first grade in a while.
Okay. It'll come back to you. May I? Well, like I said, with my next example, let's commit to allowing u to be equal to that radical nasty business. I think du is complex, cumbersome. I don't want to deal with it. So if you don't mind, I will cube both sides just to make my life easy. By the way, everybody, if you don't do what I tell you to do, it's fine. You can relate du to dx right away. It looks nasty, but at the end, you're going to get the same thing I get. But again, you see me commit to silly arithmetic errors all the time. I'm just trying to avoid them. And now relating du to dx. Well, here it is. Here's the relationship. Let's dive into things. My original integral was this mess. However, making my replacement symbol by symbol, I think everything upstairs has a new name of.
U.
What's another name for what's downstairs?
U cubed minus 1.
What's another name for dx?
3u squared du.
So I think in the end, I really have the integral of 3u cubed over u cubed minus 1. I'll stall for a minute. I'll let that marinate so you can tell me how to continue. You guys feel like you're becoming integration machines at this point? Or do you need some more oil?
Oil.
I think the oil comes to play here. It's a rational expression. However, it's not proper, is it?
Well, you have a difference of 2 cubes at the bottom.
True, but I want you to concentrate the fact that it's not a proper rational expression. So it screams out at you. Add what? Add what?
0.
Add 0. If I add 0, oh, sir, I see what you're saying. Okay, I get it. But I still maintain, what I'm really going to do upstairs is add a funky looking form of 0. The funky form of 0 I'm going to add is minus 3 plus 3. So I get this. Or shall I say, I get this. Okay, you guys, I gave you a little bit of oil. That means I'm now waiting.
Oh, we're digesting.
Oh, split it up into...
Now what? Okay, but even if I split it up, I still think I've got some work to do.
Then,
Partial fraction decomposition.
but couldn't you split that up to the difference of 2 cubes before you do that?
Well, I think when she said that, she's assuming I did.
Oh, okay.
So I agree with you. Yes.
When you split the first part of it, I see where you split up 3u cubed minus 3 and took out the 3. Why wouldn't there be a 3 in
Yeah,
step
what
1?
happened to that?
You see what I'm saying?
What do you mean?
Yeah.
Well, do this. Close your eyes for a minute. I don't understand what you're saying. And you guys, I do think my last integral is a prime candidate for partial fraction decomposition. Because I think what I have downstairs is nothing more than the product of this binomial with this trinomial. Do you guys agree?
Yes.
Oh, really?
No.
Well, I still think I factored correctly.
Oh, yeah. Send it
Okay.
later.
Nice, nice. Now you're saying pull out a piece of scratch paper. Commit to partial fraction decomposition 1 over u minus 1 times u squared plus u plus 1 is equal to my a over u minus 1 plus bu plus c all over u squared plus u plus 1. And now I can remove parentheses. You guys hear me? Am I doing okay so far? Seriously.
Yeah.
Let's see if we can generate this quickly. I think if u is equal to positive 1, it tells you that a is equal to 1/3.
Okay.
Oh, okay, let's see it.
Do you want me to come back? I will.
I don't know why I'm confused about why you're adding -2 plus 3 or -4 is like at the first.
Gotcha, gotcha. Don't look over there yet. Wouldn't this be really nice to have? I'm serious. Because now I just cancel. But I can't do this. You know, technically speaking, I started out with a 3u cubed. Can I put it in up there? Because that's what I started with. But this doesn't work, does it? It doesn't work because now I don't get the cancellation. So can I change it? Can I multiply that term by 3 as well? At least now I get that cancellation, but you gotta confess this is not legal. You know, technically speaking, I only had a 3u cubed upstairs, not a 3u cubed minus 3. I'm the one who just put that in as a term upstairs in a numerator position, so I gotta compensate for that by, I don't know, putting it back in. So that I've effectively added a funky looking form of 0 to the numerator. And like I said, if you don't like what I'm doing, don't listen to me. You can always get the same darn result by performing Pauling long division. Divide that into the half. Yes, sir.
Might be a little behind, but I don't.
That's okay.
I don't know when you would use like the BU plus C rather than just the B.
And here's one. If your denominator is quadratic, degree 2, your numerator can be as big as degree 1. Now I use the phrase as big as because B might be 0. I'll find that out later. But because it's degree 2 downstairs, upstairs can be as big as degree 1 and have to be linear, not just simply a constant.
So if it was just U squared underneath there.
Doesn't make any difference. I still want a BU plus C upstairs, because if I just had a U squared downstairs, it's still quadratic. My denominator is still of degree 2, and so I want my numerator to be as big as degree 1, which is 1 less than
But
2.
if it was alone, if it was just U squared alone
Without the U plus 1, I think nothing would change upstairs. I still think I'd put up that linear expression. Because just with that one term, it's still quadratic. It's still a degree 2, so I want my numerator to be as big as degree 1. Well, what about the rest of all this garbage? Equating coefficients of u squared, doesn't that clearly tell me that b is equal to 2/3?
Don't you want to set u equal to 0? Because that'll cancel out b and make it so you can solve for c.
Okay, if you insist. I
Just by
wouldn't
plugging
know
in the
that.
value for a.
So you're saying you want to set u equal to 0?
Yeah.
That means a minus c is equal to 1.
Yeah, but we already have the value of a, so.
Does that mean it gives you negative 2/3?
Yeah.
Well, let's put everything, yes, I'll hold it.
What is u squared equal?
No, I was saying equating coefficients of u squared.
Oh, gotcha.
You know what? I think I made a mistake. I'm so sorry, you guys. I did the arithmetic in my head. Equating coefficients of u squared gives me a negative 1/3, not a 2/3. My apologies. So what's the point of all this? You don't know. What's the point of
The
all this?
point.
By the way, you guys, I did not realize this. This is a really good example, which I wanted to talk about in my next list, in which I'm applying multiple techniques of integration. Notice how I started off with a rationalizing substitution. Now I got to deal with this darn partial fraction decomposition, and when I'm done, I'm still not finished. I might have to deal with some kind of trigonometric substitution, maybe even completing the square. This is a really good test question, because it involves you applying multiple techniques within one interval. Let's plug everything in. Yes, I'm sorry, Jerry.
You said earlier we're doing partial fraction decompositions and let's see, the
quadratic, you have the bx equals c. Let's say for that one, on the left-hand side, you had the u minus 1 quantity squared.
Yes.
You would add like a, I don't know, like a d plus, or d over the quantity u minus 1 squared, right?
Yes, or Jeremy, do this. You could have just said, keep it, have the u minus 1 squared right downstairs, and have an au plus b. Either way will work. You can either treat the denominator as quadratic or repeated linear. Whichever you want. I promise you, in the end, you get exactly the same.
But if it's easier to do it, treat them as linear, right? 'Cause-
For me, it always is. For me, I mean, I can't speak for this entire class. You guys, I'm running out of room. Can I scoot this middle portion right here and erase? Let's see what you get. And if you don't want me to finish, you guys, I won't finish if you don't want me to. But at minimum, if you don't want me to, let's talk our way through what's next. Let me substitute back in. Does that give me my 3u plus my 3 times this integral? Or I got my a over my u minus 1 plus my b, which is negative 1/3 u, plus my c, which is at a negative 2/3, all of my u squared plus u plus 1. You guys, is it okay if I just slough off the first integral? It is such an absolute piece of cake. What would you do with the second integral?
Completely scratch.
I could.
Wouldn't it be 3 on that? Oh, no.
What's the derivative of the denominator? What's the derivative of your denominator?
2u plus 1.
2u plus 1. And so it'd be nice if I had a numerator in a situation where I had something like a 2u. Is it minus 1 or is it plus 1?
Plus 1.
Plus 1. I would like something like that upstairs. So I think upstairs, let's write a negative 1/3 u minus 1/6. Because now if I pull out a negative 1/6, that is a 2u plus 1. Is it driven by denominator? It's not legal. I mean, I really had a negative 4 to 6, so that means I got to compensate by having a negative 1/2. Isn't that nice? Seriously? Because that means now I got a 3u plus natural log of stuff. Is that a minus 1/3? Integral of a 2u. I misspoke. I meant minus 1/6. 2u plus 1 all over stuff. Oh, I forgot my minus 1/2, didn't I? So is that a minus 1/2 times the integral of a 1 over something with respect to u? Where the something is just u plus 1/2 squared plus 3/4. Now that's slick. I said, now that's slick.
Is this still example number 3?
Yes, student example number 3. Yes. That's what I'm saying, it's a great test question, isn't it? Also, yes, it is.
So I see how you can pull out the negative 1/6 from the first two of
Yes.
the 3 top terms. But once you move it to the left, isn't it applied to the negative 1/2?
Applied to the data?
Applied. Because now it's multiplying across the whole interval.
Oh, I didn't. You know what? I took a mathematical axe right here, so the negative 1/2 is still associated with the second integral. I only pulled a negative 1/6 out of the first 2 terms upstairs. And the last term I left as a negative 1/2, I just pulled it outside. And I think, I don't know, we just